to start with, I thought of talking rather than bridge design or specific thing. I thought of talking a topic like what is the role of bridge engineer when you are delivering a bridge design and construction project. So I can move the slides here, right? Yeah, this is about me. And then this is a disclaimer. I always put this one to make sure that because the certain element I get the country I'm living and working, got a lot of PI and copyright issues because of that. It's very common to me. I put this disclaimer, inform the audience that the thoughts and opinion expressed in this presentation belong solely to the presenter, me, and not necessarily to the presenter's past or present employees or any organization or any individuals. The information in this presentation document should not be used for comparison or evaluation of the other works and against any individual or any organizations. This document should be used only for educational purpose, not for any other commercial purpose. The sole intent of this presentation is to share my engineering experience with the future generation like you and the betterment of the engineering and well-being in the society. That's the whole objective. We all engineers, we do this one. You all are very young and grow up. You can see me and Shiromal. We have been doing great work. Especially, I would like to thank Shiromal, the allowing and developing very young people to grow and replace us in the future in a couple of years' time. And then this profession will be survived. Thank you, Shiromal. Yeah. The presentation, what I'm going to talk, I see the bridge engineer are required to play an important role. To design and construct and deliver successful bridge project that will meet the intended performance requirement throughout the design line. This is a very technically sound, locally crafted and a statement. This I got it from one of the contract documents. This one says so many things. You can write down, you can analyze, and you can change it to hundreds of thousands of pages, this few lines. What are the responsibilities and challenges and you're going to face when you want to meet that particular requirement? Frankly speaking, I can't go through each and every one of these things, but I try to focus on this talk. Understanding project stages, like you all are young, and then you all need to know what are the project stages and what are the common objective when we are setting this. Understand common bridge type, because certain slides I will pass very quickly. Understand major issues in the design and construction. What are the risks and how to assess them? And then safety design, structural design, QA, QC processes, and registers and design tools we're going to use. Then these are the elements you have to at least know as the bridge engineer or then as an structural engineer. Yeah. You see, I'm going to talk about role of a bridge engineer. Then I just put a photograph. Someone is, yeah, you can see that beautiful lady and his partner or boyfriend or husband. Yeah, they try to hang this wall, this photograph in the wall. Yeah, this is the project I'm going to talk about. Right? You see the, yeah. They want to hang this photograph on the wall, right? The first thing, the project is, yeah, hanging this photograph on the wall. So before you hang the photograph, you need to find the photograph. Find that photograph, someone has to draw it, right? There should be an artist, like a client, right? This is the client as well. When you buy the photograph, you need to have agreement. You can have an easy agreement between the stakeholder, but it's very difficult to have agreement between us. Trust me. You'll get to know this someday from your own experience. And then this agreement is really hard, which one to buy. Because otherwise you buy and I don't like it, I ask you to what you want to make it other, right? There will be issues later, right? There are stakeholders, you need to get that agreement. Once you bring this one in, so you need to spend, because there are photographs, if you buy, you can buy for 5 rupees, but you can buy a photograph for hundreds of millions of rupees. Yeah, it's for a wide trade. When you build the bridge, you can buy a simple span bridge, you can buy a cable stay bridge like you have now over the Kalani River. The investments and the amounts of money is quite big. So when you are hanging this one, you can just go hang on the top of there and when you can't reach them. You need to place it nicely once you put that, but you need to match with this around and the environment, right? So when you design a bridge, you need to make sure that that bridge will be matched to the environment you're going to get. And the same way, you see if this guy is you try to put the nail in there, like put a gun on it. You might hit the spring, right? So you need to worry about the risk and the safety. If you not properly keep the nail alignment, you might damage the wall, right? So then you need to make sure that your quality, you get it right. And this work is a team work. The process from collecting money, discussing how to buy a photograph, and until you hang this one. Yeah, it is a collective team work. Bridge and any engineering, whatever you do in the office, is all about a team work. Then you can do everything and hang the photograph that both of you like, but once your friends you invited for dinner or something, they should be able to appreciate that. It's like we build bridges that people start driving, right? The user should be able to appreciate that. This is the whole process. Beyond that one, after a while, this photograph, you need to take it out, you need to be disposed. This is the real thing. If you do a bridge or if you do a building or if you build anything, exact same thing. This young couple is saying. You start with planning and you start with execution stage, you evaluate the risk, you look at your budget and you see what you can achieve. Then you get on top of that, you should be able to appreciate what you have. So this is all about in the engineering. This is what we always do. Because the engineering is not about design and construction. The design means you got artists, you do that. Construction means you bring that, pay that, and then hang it. It's not. It's much more there. So you all need to appreciate that. Always need to remember this one. Other thing is a massive teamwork. You all are structural engineers. You have to work with many other disciplines. Example, geotechnical, highways, right? Drainage, and so many other disciplines. Electrical. So many other people. So when we were doing the project, so what we're going to do now, for us to work this complex work, you need to break down into simple processes to achieve that complex project, complex work to get the final outcome. Otherwise, it's becoming a mess. So all the time when we work, we need to have a process. Like for example, when you are designing a beam, right? Simple beam, right? You do a simple analysis, right? For the simple supported beam, you get a bending moment WL squared by 8, the maximum one shear force WL by 2. Then when you design, you were guided by the design standard, you not do the way you like. So because of that, there are processes put in place. So in a bridge, when we were doing this one, we need to understand the stages in the project. That is starting with the planning. that is first started with planning. That young couple, they wanted to buy that photograph. They think about that. They discuss about that. Like the planning stage, this is like few hundred meters away, that road development authority, the client, they have to do the planning work. And when you do the planning work, for example, let's say we want to build the bridge next to this, there's a canal or river going next to the building. We want to build the bridge. Then we need to see how we're going to plan it. What are the consequences? And then whether it's feasible or not, we have to do a feasibility study, right? So whether we have enough budget, what impact we have when we were doing the environment, community, right? So you might do everything, but then the group of people might come and say, no, we don't allow you to construct that particular bridge because we don't like it, right? And during service, because if you build the bridge, you get invited a lot of traffic pass through that one, those impact. You have to do feasibility studies. Once you do the feasibility studies, you can decide this particular route or particular bridge types we selected is right solution or not. Then once we have this document, we go to the tender stage. There are many phases in that. Once you do the tender stage, this is the preliminary work. You can see I combine them together. It's mostly done by the client. They might hire some consultant to do, but it's mostly done by the client, like in Sri Lanka, it's RD. Then they will invite a designer like you and a contractor to go hand in hand to design the bridge and construct it. Once they finalize that, they're going to hand over this one back to the client. So the client vehicle is going to use the bridge. It's going to be, they're going to be used for almost 100 years. You'll know while you are driving the issues you are facing on the road. So they need to maintain them to make sure that it is usable for the commuters. And then once the design age is over, you have to decommission this one. Now these issues are surrounded by, I think, the current issue. Maybe you heard about the sustainability design requirement. They were quite critical. Environmental design requirement, they play a vital role in when we doing the bridge design. When you are doing this work, you have to engage with the stakeholder. You need to manage them. There are a lot of risks. You need to manage them. Then you need to make sure that whatever the structure you propose is got a value. We do value engineering, or else we call the word value for money. And then we need to make sure that design and the construction need to make sure that we do to a right standard. We need to make sure that we have a quality control and quality assurance. Then we need to do project management. We need to consider environment sustainability in addition to maintainability, etc. These are the elements, main element in the project stages. This is a procurement stage. This is the design detail stage. This one is the maintenance stage, or where the people is going to use. If you look at, like I mentioned before, that photograph story, you can link the same thing in here, but in a larger scale. I just put this slide. We have been seeing this one before as well. When we were doing a project, you need to understand what are the objectives of the project, especially the highway. When you are building a highway or the roads, the main purpose is to improve the road safety. Please remember that. That's the main purpose we are doing. And then improve the efficiency of the highway between proposed destination. Efficiency in the sense you can drive safely without any difficulties like traffic jams and other things, and you can reach your destination as quickly as possible. Then we need to, when you are building a bridges and road, you could see around the country now the economic development in the country. Especially you can see between these highways open up in the country, economic development, like especially the land values, they go up like tenfold, I don't know how much, but yeah, it's really the impact on the economy. And then when you design everything, it needs to provide value for money. So you can't spend 100 million if you can build that from 80 million. So you need to make sure that you build that fund for 80 million. And enhance the potential beneficial economic effects, manage potential adverse environmental impact. Because, for example, I think when you are constructing something across the river, right, you can't just go and build a dam or something to build that one. You can't go and put all the piers in the bridge like 10, 15, 20 piers over the river, right? Waterway. You need to make sure that, let's say that river people use the boat, sometimes use like some not common in Sri Lanka, but most of the countries they use rivers to transport the people, right? Sometimes they allow ships to go under the river. So in this situation, you need to make sure that you consider those things. I'm not going to go this one in detail because because of the time. You optimize the benefit and minimize the adverse impact on social environment. Because especially the reason is if you are building something, the people are living neighborhood, you need to, for example, transport a lot of material to that one, right? So when you are building a bridge or a building, you need to drive big pile, you need to have a big pile drivers, and then sometimes you need to break elements like concrete, it may generate a lot of noise. So you can't use them like in the 12 o'clock in the night, that's a good time to work. Yeah, no heat is a good time to work, but you can't do that time because neighborhood, people should be able to sleep. So you need to consider that. I'm giving very simple examples, not the very like a complex one. Yeah. Then when we are doing the work, we always bound by the contract, right? Bound by the contract. So the contract types we use in the design, we call design construction type. Construction to the client design, you do a detailed design, and then the alliance in designer contractor and the designer contractor and client. A client work together, alliance. The other one, public-private partnership. This project is invested by the company, private entities. Like, for example, you heard about a lot of talking in Sri Lanka that the foreign countries, they would like to invest for the elevated highway, but they collect the money from the toll. You have to pay the toll. So those investments, and then you need to work. So what I try to say in summary, when you design anything, it's a different level when you become senior engineer. Then you have to deal with this kind of documents, the contract documents. You need to make sure that because your design and your compliances is always comply with these contract documents. Yeah. Sometimes you started your career, then you do calcs and you do designs, but when you go up in your ladder, so you have to deal with them. So we are, for example, in the office, we deal with them. There are a lot of issues come. When you try to solve them over the code, it's going to cost you the loads of money. And in addition to that, there are a lot of risk associated that you will see later on how we're going to mitigate. Then when you are doing a bridge project, so we talk about the stages in the project, and then we talk about the objectives and contract. This is in general I'm talking about. I'm not going into very specific detail for every one of you to understand it. And then the parties involved in this one. We always got client. He's the key person in here. Then he has to deal with external agency. He has to deal with communities, environment, and especially the funding. And then he had to deal with designers and contractors. And then designers, when they do design, they have to deal with all these people. And when the contractor will start constructing, they have to deal with each and everyone. They all are interconnected. They all are interconnected. It's a complex process. Sometimes you do calculation as a structural engineer. When you go a couple of years later, you need to manage that. You need to manage these processes. You need to manage these processes. Then the bridge engineer, that's what I said. It's not the person do number crunching. That's a word we always use. You have to think out of the box, right? If someone, for example, when you work, your geotechnical engineer, if you say, mate, the load you did, I can't design this foundation. And you can't tell him, no, I had to redo my analysis. I had to go back and change my thing. No, I don't want to do that. It's not the way. Then you have to first sit with him. You don't want to accept. He say, no, I can't do that. You don't want to say, no, I'll go and change that one for you, man. No, it's not the way. You have to sit with him and can ask him, what is the issue? What is your problem? So you can't design for what? Is it the ground is not good? For example, if you design one in the water, one in the soil, if you get the rock is shallow, if you have to go to the sand, you got a water table high. There are so many issues he is facing, right? And you need to sit down and have a chat with him, have a good conversation, and to discuss. Sometimes you can explain, oh, okay, we can do in a different way. Sometimes the way you do your analysis, all the time geotechnical engineers do. They ask you to give you the top of the pile top, the loading, vertical, horizontal, and moment, and they put that one in the L file and they say, this one is 70 millimeter movement in the pile and you got a massive bending moment. But in the bridge, he never considered the stiffness in the massive bridge on the top, right? Then you have to go and reason out with it, not like say, oh, no, going to go and then next step, both of you come to a common understanding. Is that solution is feasible or not? If not, you go back and change. This is the teamwork plus the understanding of the other discipline work as well. Yeah. This thing will be when you go up in the design, when you go on your process, you will be going to face it. But we have to solve it because we are a team, we need to deliver. Remember that simple example I talk about all the time, hanging a photograph in a wall. Exactly same thing. You're going to repeat. Sometimes you have to repeat 100 times, maybe 1,000 times, according to the complexity of the project. I'll just put this slide, the understanding common type of bridges. You should know what you're going to build first. But I'm not going to go this stuff in detail. The simplest form, because the reason is in my bridge design lecture series, we went this one in very detail. For the sake of the completion of the presentation, I included them here. The common bridge type is the very simple and cheapest form of bridge type is the PSC flank bridge. You can see it can go up to a few hundred meters in length. Yeah. In kilometers in length, you can build. Yeah. This is in terms of the bridge construction and the design and the cost-wise, the cheapest form of bridge. Then I-beam or super T bridges. This is very common in Australia, one of the most common in Australia. 78% of the bridge they design using this method. Yeah. And they use the longest one, I think 3.5 kilometer long bridge. They use super T, a 30 meter span, you can see, the 120 plus span in the bridge. And these are the way they build this one, construct in this one. And this is one of the bridge I will design and build. You can see column, frame, erect the super T. You can see the way they bring the super T down up in the valley here. And you can see the way they raise and place these girders. Each and every activities, if we talk about here, you're going to learn later. When you are designing a bridge, this slide is very important. You need to consider everything, every element in this. For example, We are working on a valley here first. That's where we put this bridge. You can see that's why we have told column. This column are shorter, this bigger. In the valley is going. Get involved there. Any question? Don't worry about whether it's right or wrong, or is it relevant or not relevant. Doesn't matter. Please ask. Yeah. Don't worry.
Yeah, that's right.
Yeah. Thank you. So.
You may send your questions on the chat as well, and then I can ask Mr. Rohitha. I can read it out loud to him.
So you need to bring the machines in here, right? Once you bring your machine, you do your file, you do your footing, you go up the column 25 meters high, right? When you are doing here, you all good. Then you go to the top, you have your cross like this. Once you are building cross beam, the people are working 25 meters above ground. You need to make sure that they can construct this, right? So once you construct that, you need to erect the girders, right? You need to erect the girders like 25 meters above the ground. You need to reach them. You can see one of the in the presentation, the picture. Yeah, in here you can see the bring this one. You can see they erect the girder. Actually, I forgot to put that slide in here. While they were erecting the girder onto the bearing, there are a lot of people standing. You can see one guy standing, other guy here, 25 meters above the ground. So you can imagine if he slip, it's going to happen. That's what I said. Brick engineering or any engineering you deal with, like you are designing very tall building, right? It's okay for 2-story building, right? But when you go up, you can see the logistic issues you are facing, right? Interfacing issues you are facing. You need to make sure you consider all of them when you are designing. But I try to say, listen to your friends. Sorry, I try to say mates. Listen to your friends. Listen to your friends. They're from geotech. They're from the drainage. They're from utilities. They're from highways, right? They're from services. They're from urban design. You have to listen to your architects, right? They may say, like, we need to have this one. It's a heritage issue. You need to put that stuff on the bridge. You can say, no, it's very difficult for me to do. I don't like it, right? It's going to cost too much. I can't do it. No. Once you finish this, it's used by people. They are not structural engineers, right? Only a handful of structural engineers in this country and around the world, in Sri Lanka. If we can bring all of them and we can ask them to stay in this plus standard, right? So we have only very few, right? And some of them already left the country, like me. Right? So, right? And again, a lot of people are leaving, right? So you need to listen to your friend and you have to work together. That's the beauty of working in India. That's the beauty of working in India. I keep doing. You can see how beautiful when you build a kitchen, it's matched with the surrounding. Yeah, that's what we need. The other type bridge is a launch type bridge. This we normally use, like if you build a bridge, especially in the Colombo area, like the is already up in the air because sometimes you got opportunity from over the side, like a railway line, right? Sometimes we use the launch bridges here, especially over the railway lines, very common. It's a massive process. It's a very simple thing. You build the bridge and you push. It's like pipe jacking. You heard about pipe jacking. Exactly the same thing. Pipe jacking do underground, launching bridge do above ground. There's no difference, right? There's a difference, but the principle is the same. When you are an engineer, always think, what is the basic principle we're going to apply in an engineer? Like, always think about this guy came and talk about the hanging a photograph all the time. Huh? That's a story you need to take home. Yeah. This bridge type, I never recommend, or in Sri Lanka, you're never going to use it. It's called voided slab bridge. Now, in terms of the current sustainability designs, requirements, we can't use them because these bridges are very heavy and it needs a lot of concrete, it needs a lot of force tension. So therefore, this type of bridges still in Australia we use because of the labor cost. but it's not the one type of Sri Lanka, but it's still I put. The reason is if you go to sustainable design, yeah, from the list of bridges you propose, they will take that one straight away, take that one away from your list. Then you can go to more complex bridges. I think you already seen there's a one now over the Kalani Parliament, a beautiful one, right? Cable stay bridge, but a balance continue a bit. I think you have seen this kind of interchange while you are driving on highways now in Sri Lanka. Yeah. In the future, we need more. Yeah, you can design. Then when you are designing the bridges, not only bridge, this highway project is always cut and fill business. Our highway engineers, when they're doing the design, they try to balance out cut and fill, right? But when we were doing that one, for example, when we were constructing a bridge through, and you need to excavate certain area. This particular project, we had to excavate about 20 meter maximum deep, about a half a kilometer length, right? So then we need to identify how to excavate that element. This is about it's about 30 meters wide, right? This is the rock, right? We need to come up with the best possible retaining structure solution to solve that problem. Otherwise, it's very expensive, right? Like in the city, when you are building when you are designing a building, when you go to the basement, you keep going down to get the car parks and other amenities. So what you're going to do, because when you are doing a building, you are constructing right next to another building, you don't have land to play with. So then you have to go the best, robust design solution, like a contiguous pile wall. But for example, I'm in Sydney, we are very lucky. We got sandstone everywhere. You can cut this shape like cheese. It's very easy. That's cheap as well. You don't want very expensive retaining structures. In this one, we have many retaining structures in this particular project. One of the new retaining structures, I think you may not have seen many, we call the soil nail wall. It's very easy. You excavate the soil, you put a nail and shotcrete, right? It's like, think of yourself, get a piece of paper and like 4 or 5 paper you want to attach to the wall, right? You glue it, you nail it. Like if it is a piece of paper, you can glue, but piece of timber, like a series of photos, right? You have to nail, right, to attach to you, right? So when you are excavating the wall, what's going to happen when you excavate here, this bit of the soil is unstable, it's trying to fall down, and this nail will hold back like I don't know, you guys never experienced, but we experienced that, right? You cut a tree, put a rope on the top and pull that one down, right? Yeah, it's the same principle we use here. We have those lifetime experience. That's why the design this stuff for us is very easy, right? Go and try that one at home. Yeah. Make sure your parents make all of them insured before you do that. Right? And once you keep going down, you can excavate this and keep adding the nail. This design is the beauty of the collaboration between structural engineers and the geotechnical engineers. This is one of the cheapest retaining support solution for deep excavation. Wherever possible, we use this solution. Yeah, wherever we use. Because you see, you excavate, drill a nail, right? Put shotcrete, drill a nail, shotcrete. You keep doing that, right? So then you don't want to build massive contiguous pile wall and the anchored the pile wall systems. This is the way they build it. You can see. You can see it's drilling this machine. 1, 2, 3, 4. The 5th one they were drilling, right? The average height is about in here is about 8 meters. The excavation. Yeah, and then this stuff body. These are the strip rate to capture the water behind the soil, because most of the retaining wall failures we encountered because of the water, the poor water pressure build up behind the retaining wall. This is we designed this one for this 150 millimeter diameter hole we drill, a 15-degree angle. You can say this is the retaining wall. We use the galvanized steel, you can see them, and even the soil nails. But in addition to that, we call double corrosion protection system to make sure that this retaining wall lasts minimum 100 to 120 years without any maintenance. Yeah. Another type of the one, I think I heard, and some of the in the motorways we use this one, what we call the reinforced soil wall. We use soil nail wall for the excavation, for the cut. But we use reinforced soil wall for the fill. For example, in here, this picture, you need to elevate your road, then you need to fill. When you are filling this one, this is the one of the cheapest form of solution. The principle of this, we call the mechanically stabilized earth or reinforced soil wall, different technical term. If you think about this one, the design principle is like a rigid block retaining. You consider this whole thing as a rigid block. In a retaining wall design, what is going to happen is very simple. Geotechnical engineers always talk, but they do very simple calculation. You're going to pressure in the triangular distribution. You're going to water pressure in the triangular distribution, right? This force will push this one that way, right? Or else it's try to rotate at that. If your weight is good enough, right, then it can develop restoring more. The weight is sufficient and the friction between the surface, soil to soil, new time up, right, will prevent this one moving. Then with the empirical formulas, research and all calculations, they basically decide what the length of this box is. In general, it's about 0.7 times h, 0.6 to 0.7 times the h. So that's what you need to know. And in here, the snake, we put the straps, we put one by one and build up this concrete block data. Because you don't want to argue about the stability of the structure, because the structure, once it's finished, is quite taut. So during your construction, this is a shallow depth that is always stable. This is the performance of this particular retaining wall is mainly depend on the quality control and quality assurance of the site. Yeah, it's very important, the type of material you use. You can see this particular picture, while we are building this retaining wall, you can see the type of material. This looks like the no-fine concrete in here, just the roller compact. Yeah, it's very important to make sure. Otherwise, the system will be collapsed, because you've got a lot of water building up in the back. Yeah, over the years, it will slip. Once it slips, it will take away with the rest of the soil retained behind that one. You see, once you do that one, it's a nice outcomes here. Other structures, I think these are not common, is the arch bridges, culvert arch bridges, the precast arch. Is it common in Sri Lanka? But yeah. Okay. Yeah, underpasses. Yeah. And because of the safety and other reason, now it's not common. Yeah. Okay. Are they because of the unstable force? Yeah, that's one reason they don't allow. We know they are not common. Yeah, yeah, and safety reasons. This one is we normally use for both drainage purposes and for the highways. We use box culvert. Yeah, this is very common. Like when you are designing roads, you need to have a lot of drainage system to make sure that because building a road is like building a dam to me, kilometers long dam. So people live on, now you build the road, you separate them, and you make them elevated, and when it's rain, the water will fill. If you not properly manage the flood in the downstream, or the upstream, people will get hurt, right? They will be in trouble, and then the water can bear up the highway. It might, everything might like the brake, and then like you open like a sluice gate. People living downstream also might be affected. Yeah, you have a lot of box culvert we use. This is one of the cheapest form of construction. Any country, anywhere, if we use it, because it's much cheaper than building bridges, because you put this shell and then you put a link slab on the top and you backfill. You can backfill up to 15, 20 meters above this level. Some very, very strong structures. Very, very strong structures. Because it's a shell structure, right? And this is the other road furniture and other. Yeah, the noise form. Like sometimes you might see in some highways they put up noise walls. Yeah, and another thing, this is quite common, especially in the highways. You have to put throw screen. The people might throw something when you are driving underneath. If it is a hit, your windscreen, no, sometimes people might die, because if something impact was going to happen, driver is going to go uncontrolled, then he might go and hit someone else, right? These are very important. These are the minor things. When the people design a bridge, you think the most important thing in the bridge design is to design that big girders, right? That is the bridge design. That's nothing. You know what? That girder is never going to fail. You trust me, right? Right? Even if you under design a bit, it's never going to get failed. That kind of safety is built into there, right? If you want to learn more, you can go to that, my 4th lecture, I think. I talk about bridge loading. I see the size of amount and factors we put. Never going to fail. Only time it's failed during construction, right? Like that arch pitchway. Once you complete that one, it's not. These are the other type of bridges used for animal to cross. Yeah. Animal to cross. The reason is the environmental issues you need. You can build highway through the forest, but you can't disturb the people on that land, right? People on that land, yeah, right? Can't disturb. I'll stop that part in there, then I will go to more qualitative kind of a discussion later on. Any question up to? Yeah, we do a risk assessment. Barriers, we have 3, basically we call low performance barrier, regular performance, medium performance, high performance barrier. This one related to, we call the MASH test, because they do the real-time test and certain truck with a certain speed. Those MASH testing, they categorize TL 1, 2, 3, 4, 5, 6. Yeah. For example, the medium performance barrier is equivalent to TL5. Regular performance barrier equivalent to TL3. I don't have this information with me in this presentation, but I can send it. But we can do a risk assessment. In my presentation, I discussed that one in detail in the bridge design one. We do a risk assessment, then we can decide which barrier is suitable. Even, for example, if you design a car park, or if you design something like, for example, let's say we want to design a barrier, we want to do that car park here, because if someone drives through, he will end up in the creek or water down there, right? To protect that one, we can design to suit, because the reason in here when we are riding a car is not riding 60 kilometers per hour, it's about 10, 15 kilometers per hour. Sometimes maybe he might not put the handbrake or something, the car might slowly go. Yeah. So then the impact on the structure is very different compared to the road traffic barrier, like on a local road against the highway. There we allow you to drive in 100 kilometers per hour. So any question from? Huh? You all need to talk. This is one thing I think our country, Sri Lankans, are missing. Even the people born and bred in there, they are the same, right?
Okay, one question I have is when slides will share with the slide. So I will read it out loud.
Yeah, definitely. Yeah. So I just put this side few issues, the understanding major design and construction issues when you are doing the bridge or any project. Environmental and community, this is one of the major events. This is because especially like in Sri Lanka, when you do certain thing, the people have a massive involvement, like the media, social media, politicians. Like for example, in Australia, we don't have that problem. They really understand if you say we're going to build this particular one, that before they do, they will say pros and cons. These are the impact, but these are the benefits you're going to. Right? And sometimes it's not going to benefit directly to you, but it's going to benefit to the country, to the people, that they have that understanding, right? This issue is very, very critical in here because sometimes you might design, you might start, you might build the road halfway through. Yeah, you have to go back and change the alignment and do the, right? It might happen. So this is one of the main issues, but it's not, there's no engineering solution to that one, trust me. It's how you're going to negotiate and how you're going to get a common understanding and solve this one. In terms of the engineering terms, the flood, noise, vibration, the cover, navigational requirement, these are the engineering issues we need to solve when you are designing. Why flood? If you are designing a bridge across the creek, the main design criteria is flood. Because if you build the bridge, when there's a small rain, if it's go underwater, there's no point having that bridge. Right? The whole purpose of having that bridge is people to cross the river or creek. Then you need to estimate. When you are estimating the flood, no one in the world can estimate the amount of flood. It's very difficult to estimate. If I give you one classic example, recently in Melbourne, you got a bushfire, right? It start burning. They evacuate people. And it's like out of control bushfire. And it's keep going, and then next day or 2 days later start raining. And the whole river is flooded. And they ask people to evacuate again. First, because of the bushfire, and the other one because of the flood, right? The reason I gave that example in here, when you do the flood design, because of the climate change impacts, very difficult. No one is able to predict that one. We need to have a reasonable assumption. We need to take as a reasonable risk when we design this. The benefit you're going to get from that one is massive. Every time when you do certain changes, certain things, there's a capital cost associated with each other, right? The rupees and dollars at the end of the day talk everything what we do, right? So then you need to be aware of that one. But as initial investment you're going to make, it's a lot of benefits. The cover is another thing because most of the bridges is failed because of the flood is washed away. You need to make sure that your bridge might damage, but it's not going to wash away. Yeah, it's a very common problem. And then if there's a navigational requirement, if you even let the small boat to pass under the bridge, you need to make sure that you have enough room to play with that. Yeah, you can't say my bridge. I can get the economical bridge design if I put a pier right in the middle of this river, right? Then ask the other people to take a bit of a turn and go back, right? You can't do that. You can do a small boat like riding this small one, but if a big vessels, you need to make sure that your navigational channel already used, let them to use. And heritages, flora, fauna, because I just the Aboriginal, but in Sri Lanka is one of the key things when you are everywhere you drive, you can see the bow trees, Buddha statues in there. So once you design a highway or want to do something, there is always an issue to get your road aligned, right? You need to find the way to work around that one. I really don't think you can never cut that and go through that one. But only thing, you need to find the way around and you need to get a compromise So certain distance we take our highway around, right? Because sometimes other people might take, when you even take around because of the smoke, කාලයකට පස්සේ ගහන්නare ඒක නිසාවට හදන්න දෙන්න බෑ, right? Sometimes you need to deal with them. These are not engineering, these are not calculation. These are the real thing you face when you are designing and constructing. It is a lot of things because you do everything, but you can't do that on the side. What is the purpose of designing that? But if you can't build it, right? You even design landscaping. You saw that previous picture. You need to make sure that whatever you build, the people is going to use, as I mentioned, not this maybe less than 3,000 structural engineers in Sri Lanka. Rest of the people, like, body as long as nice, smooth ride, and when they look around, if it is beautiful, they are happy, right? Then you have to make the rest of the 25 million happy. So make sure that you consider that when you design bridges. And the safety, the durability and maintainability. These are one of the very important things in Sri Lanka we must learn. I'm going to spend the next few slides to explain this one. Yeah.
There are a few questions from the audience.
Yeah.
So the first one is, what are the standards that are widely used for building bridges in Sri Lanka? PS or Eurocode?
Eurocode.
Eurocode is what you see.
Yeah.
Okay. The next question is, someone says, currently I'm working as a site engineer in a bridge project in Sri Lanka. In my project, we are using temporary sheet pile shoring to retain the soil and provide safe environment in deep excavation. I think it's more of a statement than a question. So I'm not, and is it, he's just stating, he says it is very useful if I can know the quality and the standards for temporary sheet pile shoring.
Temporary works design, there is no standard. The main reason is there is no one would like to write that one because of the risk. Yeah, because of the risk. Like if I write a code, if I let's say write something on my own, and then if someone uses it, if it's a collapse at fail, they will put me in jail for the rest of my life. As simple as that. Because of that, there's a massive risk in there. Another thing, temporary work design is place to place, person to person, contractor to contractor, client varies. Yeah, there is no one way, one solution. Because of that, the temporary work design, we design for that particular case. For example, of course, for the deep excavation, sheet pile wall solution is the common and the standard construction practices. What is the advantage having a standard construction practices? Because most of the people can build that. If you go to a very specialized one, you have to hire a specialized contractor to do that. Again, people have experience. They know this particular material, geotechnical engineers with the contractors. Before we use this type of particular sheet pile, they got a type 3 and type 4. Like a type 3, I think 60 kilogram per meter weight, and the type 4 is about 80. I think in Sri Lanka also they use the same. So you use them, and then you have the bracing around that one. So you might have a propping. These are common practices people use. Because of that, the people like to use them. And then the economy you can achieve both ways. Because of this standard practice in the industry, then once you use that one, anybody can go back and build. That's advantage you are having it. But to answer his question, like if you go to Australian standard, if you design for factor of safety, when you design geotechnical engineering, we get a factor of safety in different approach. So that factor of safety is higher. And then we do a risk assessment to decide if I use the sheet pile wall, what sort of risk associated with that one. For example, before I flying to Sri Lanka, I signed off one of the sheet pile wall design. We are designing for one of the tunnel, the sun. It's a really big sun. And when we just design the sheet pile wall, but behind you can get massive cranes and construction vehicles are running, right? So then the material also not good, right? So when we designing that sheet pile wall, it's not that designing the sheet pile wall. We need to make sure that all these machine loads, like there are some other utility services going around that one, we can manage them. Yeah. So because of that, when you make that decision, you have to look at that one. But to answer his question, of course, yeah, when you design temporary works, the codes like Australian standard, and sometimes the client, they have the particular statement they put. The higher factor of safety you need to maintain, because they don't want during construction, because during temporary works construction, your quality control and quality assurance is very different, as mainly the responsibility of the contract. Client hardly have any authority. Because of that, he can't say, no, I don't like it. He said, I don't worry about it. I don't care about it. Yes, my people go there and work, right? I think it's safe. Guys, you can't prove that. Some clients, they do. For example, when we're designing a retaining wall, we get the safety factor like a global stability, for example, 1.25. But when we're designing a temporary retaining wall, that factor of safety is 1.5. There are guidelines in the code they given, but not specific design requirements given. You have to make judgment, but certain guidelines there is provided. Yeah. I hope I answered the question.
Okay, I think so. So basically, the Australian standards have a couple of
Yeah.
guidelines that you could maybe
Yeah.
take into consideration.
Yeah.
right?
Especially in the contractual document they specify.
The other question is, generally, what is the design life of a bridge? We take a bridge when we try to design it.
Minimum 100 years. Yeah. But it will last, to me, with my experience. I'm involved in a lot of ports rehabilitation projects in Australia. Those ports were designed 70 years ago. Like when we were kids, we used to mix 1, 2, 3 concrete mix. I think they use them to design them. Even though there is no reinforcement, they use a flat bar like that. Yeah. Still, those ports is carrying like a 5 times heavier load than what they design, right? Still, they are there. I'm involved with some sustainability design projects in Australia with one of the largest concrete supplier. My argument is all the bridges currently we design, even this building, it will last more than 200 years, 300 years, because the way I compare those material quality, the way the lighter load now subjected to very heavy load, still it can last, and when we check, we know that it can last another 30, 40 years. Then current modern technology, with the way things we design, can last more than 100 years. To answer the question, yeah, if you use the Euro code, the requirement is 120 years. In general, in Australia, we use 100 years. Is 5100, designed for minimum 100 years. Yeah. 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 No, I think it goes to the first statement I put in the at the beginning of the presentation. It needs to perform its intended function with minimum maintenance. That doesn't mean that's the end of the design life is 50. Yeah. Yeah, it's like you can tell the better way to explain, Shiromal, to the insurance people, they are not engineers, right? They always move around. They are very good risk assessors. You can tell, okay, mate, like some people live 90 years, right? Some people live maybe a few months, right? Have babies. Some live in average. Our average life expectancy 70 years. So what do you mean by that? It's exactly the same thing in the building. When we say 50, that doesn't mean like it's not going to collapse like 3 years time. is going to last, that expected time is, that is the engineering principle. Yeah. Yeah. Yeah, like if they maintain, they should have. Yeah. If they maintain, they should have. Yeah. Because all over the world, like in Australia, they got some of the bridges about 120 or 130, 40 years old timber bridges are still they're using. They're maintaining and they're using, they're not going to demolish. Because the people just decide and throw it away, but they should have maintained and keep that bridge. Yeah. Yeah, it can. But the minimum design life, that's a statement I made, the insurers, that's where at the end of the day we are come, right? So PI, so we have to make sure that, yeah, all the infrastructure we insure, if there's a damage, then there's someone to pay for that, then he need to know what are the risks. I think the better way to do, we get them and we educate them. Even I can help them. That's the better approach to do. Yeah, it's got, like in Eurocode is specify 120. Yeah. That's our responsibility. I will explain this one in after few slides. Yeah. How are we going to achieve that? Yeah.
So there are 5 more questions, and I think that's the end, so that way we can maybe
Yep.
cover the content.
Yep. Here the design one, like I mentioned, right? Yeah. I'm not going to go through this one. Yeah. It's that project I work. I said that massive cut. We do soil level, you can see swept place with nice panels. People won't see it, right? Everything costs. That's what I need to say. Like you can't expect in Sri Lanka for us to do the same thing because we are still like growing up. I'm sure when you all come to our age, you can do this stuff and learn how to do it. So we will help you to go. Then the next phase of the work, I just want to touch base with the risk. Yeah. Everything is a risk. Even for you guys having a girlfriend, boyfriend is also first time. Not our time. Right? Married close to 28. Yeah. So they call new generation, right? So we are old generation, actually. So, but you need to understand, we grew up in the technology and everything, right? So we are matured generation, right? So that's the way we need to choose, right? So, sorry. When we do a race, everything is a race. Like now, Shiroma, the question asked about when you go and work with insurers, they say, what is the lifespan of the particular structure? You need to understand first what is the project life cycle of the structure. Starting with the concept development, design, and then you keep going and until demolition and resite. Yeah. Now, I think the modern day design, you need to make sure that the amount of carbon you consume in your particular design, amount of carbon you consume in your particular design, you need to estimate that. I think maybe you will learn about this a lot from Professor Priyan. And then you need to estimate that. So I'm not going to go this one in detail. I think the first slide, I went through that. When you doing the risk management process, when you do the risk, there's a standard we call ISO 3100-2008 risk management principle guidelines they provide. You need to first identify the risk. You need to assess that. You need to control them. You need to monitor and review them. I will give you a classic example. How many people drive? Right? Yeah. So you're facing every day this one, right? While you are driving. Drive this is someone is crossing right in front. It's a hassle. You need to mitigate that. Right? So every day you are, even if you are sitting on a car or bus, is still the same, right? So if you are crossing at the road, at the traffic light location, right? Someone can drive through the red line, can hit you. You get injured, they don't know the consequences, right? Could be minor, it could be fatal. That's the extent, right? So when we do in engineering, we have to assess those risks. For example, I said about that Boga story, right? It's a massive risk. You imagine you ask the company, like a foreign investor to come and do that road. They get the designers to design that, right? And the contractor, the procurement forces, they select the one. Once you about to go through that one, halfway through, someone say you can't go through your road anymore. It's not that simple to take a U-turn or turn left or right to come back and connect. It's not that simple, right? That's a massive risk you had. That's one common thing. That's community. That's a community issue. That's nothing to do with engineering. Let's say you design the road or your plant modelers not properly do the plant modeling, right? During construction, because it takes about 2-3 years to construct those. Is go underwater, right? I see next day in social media and in the news, right? Right? That's engineering and the community both issue that you missed out. Like I mentioned before, the climate change is a massive risk. And as an engineers, how are we going to assess and how we're going to manage that? We can't eliminate 100%. How are we going to mitigate? How are we going to address, right? How are we going to lower the probability of having that, right? So we need to make sure that we do that. That's all related to, at the end of the day, we go back and ensure our the infrastructure with the insurer. Then he will assess all those things. They got actuarials. Actually, I forget, I can't pronounce the name of the site. They do the risk assessment. They got a software to do that. And everything, they put a price on that. Yeah, they put a price on that. So it's a lot of key. It's at the end of the day, again, it's related to the rupees and dollars. So the engineers at the initial stage, we do this risk assessment, right? The steps are very simple. Sorry. You need to, the step one, identify the hazard, right? Then the step two, assess the risk, right? As an example, when you want to cross the traffic light, right? As a hazard, someone might, right? While you are crossing, someone might hit you. Then there's a risk, right? There's a risk. So then, what is the control measure? You should not use your phone and walk like that, right? Rather, you should look at either side. People are driving. If someone crazy is coming towards me or not, right? Hold your phone like this and look around and walk. That's a control measure you have, right? If not, right? There's the consequences with you, right? You not properly mitigate the consequences, minor injury or hit. Right? So in engineering, like that question about the temporary works is putting the sheet pile, and you are putting that sheet pile, you go underground, people are working. If it is collapsed, someone will come. Right? If that's happened in the country where I'm working and living now, the whole project will stop. They will stop. Right? That's the first step they do. They go back and assess everything, whatever they do. It's a different department for work. Right? Then legally punish. It's not the site engineer get punished. The project director is the one who gets punished. He's the one on the top. is the responsible person to make sure that project is operating in the safe environment. So we need to assess the risk and we need to mitigate. The consequences are, it's got a lot of, the consequences are very different processes, different things people identify. No need to make complex. I think the steps you need to identify the risk and assess that, mitigation strategy, and monitor and review that. Some of the risks, like, for example, when you do, like I mentioned, this particular bridge when we build, we need to construct 25-meter tall column. When you want to build 25-meter tall column, right? So first you need to do the piling, you need to get the people, the machines, along this slope. That's a risk, right? These machines are not cheap. They cost you few $1 million, right? Then, if that one damaged, who's going to pay for that? Right? You need to assess that. And while you are building this one, if someone fell down and died, right? It's a massive, someone is losing his life. How much money are you going to? You can't put a price to the people life, right? Because you and me, we all are the same, right? It's the same cost. That price, then how we manage in the business this thing? We're going to insure this. But when you design like a temporary works in here, it's not like a structural engineering. The client even required it need to be peer reviewed by a couple of people, right? Especially temporary work need to be signed off by a proof engineer to make sure that the design is nothing missed out, right? With that, we go and construct that one. Still, there's a risk. The people careless, right? They might not worried about that one, talking to someone, climbing up, and still, then we need to make sure that if they slip and fell down, doing some stupid work, still, the consequences are mine. He's not going to die. He might get injured, right? He has to go to hospital. He has to get a treatment, but still, he saved his life. Yeah. So all those things are related to cost. Yeah. There are issues like if you disable a person in a project while working, company need to pay, his insurer has to pay compensation for the whole life. Sometimes he need to build houses. He need to build particular vehicle for him to walk, carers, and everything related to that cost. Contractually, insurance has to do, right? He's supposed to pay for that. You can see insurance side must be risky state, right? The premium we are paying. As a designer, you can't get away that time because the insurer is there. He's going to pay for that. Oh, it's okay. Yeah, I want to give it up. No, you can't do that, right? In the code of law, you are responsible as an engineer, right? You didn't do your job properly. To make sure that you didn't look at that issue. So that is why the engineers, we need to do risk assessment. In terms of the designs like the pace and then the real construction work, these are very minor things. That's the thing, like people always neglect. These are very minor things, right? People always think, we don't want to look at that. No, you can't just ignore these minor things. These are the most important things. Yeah. If you are a contractor, your KPI, one of the KPI is the amount of injuries you have in the site. There are some contractors, they are pushing hard to make sure that there is no injuries in the site. That's their KPI. That's their marketing tool. Tell to the client, this project is very complex, we deliver, right? $1.2 billion project. There's no injuries. There is no exit, right? So our work is, we are creating a safe environment for staff to work, same as designers, right? Even if you go to site, you have to do risk assessment, right? Yeah, if you are climbing up a stair, you need to do a risk assessment. If you are walking in the jungle, you need to. Example, snake bite. Right? Any like reptile can bite you. Might cost your life. So you need to do a risk assessment. Like in our office, even though we are designers, we got a safety manual. But a series of forms we need to fill. Right? When we go to the sites, depending on the types, we need to go through this risk assessment process. Otherwise, they don't let you to go in their site, like wearing PPEs, etc. In addition to that, they explain you what they are doing. There are so many machines running around. You all know, you go to the construction sites, right? They are not like here, right? Noise and go moving vehicles, and then everybody is working, right? Even while you are walking, right? If you not properly wear your shoes, you might step onto a reinforcement and damage your, right, finger or your leg or your hand, right? There are so many things, and you need to provide proper access. That's why we do. You see, the people think this is a very minor thing. Why should we worry? No. That's why engineering in the what we call the like Western world, these processes are very strict. That's what I said at the beginning. Designing a bridge beam is very easy. You're designing that bridge beam is never going to collapse, right? It's never. But when you are building that bridge, right, people lives you are putting on a risk. If you are a good bridge engineer, structural engineer, of course, you need to make sure you cover all these bases here. When you do the risk assessment process, especially in engineering, we have a hierarchy of people. Eliminate, substitute, isolate, engineer, admin, and PPE. PPE, you know that. What is eliminate? Can you not introduce or remove existing hazard? Can you remove it 100%? In terms of engineering and the risk, you can't do that. You can't 100% remove a hazard. Yeah, it's highly theoretical. Right? You can say like a president guard, even if you run there as an issue. Definitely. Yeah, get a president guard will clear the road, but there are a lot of manhole on it, pothole on it. The speed they are driving is 1 foot from there. Vehicle will go out of control. Right? There's no shock absorber system in the world design. Foot here, turn around, twisting like our body, and it can walk. No. But still, that's what I say. The classic example. Like Sri Lanka, you know, they clear the road for them, right? Go from A to B. People think there's no risk, but it's still a risk. It could happen. You can't find a road without any pothole. Right? It could happen. Can't eliminate. Yeah, if you say you can eliminate, that's highly theoretical. Yeah. You can eliminate like a 99. Fine. Yeah. Then substitute can materially control the existence. For example, let's say some place you want to work, right? You're using formwork, you can use like in a building like this floor of the building, right? One is a concrete structure, another one is steel structure. Get your frame, put your beam, put the deck on, right? Metal deck, and the topping, right? This is less. You build concrete building, you can see this column you need to build. You need to build that floor, you need to have a formwork system. We don't have this good ground before that, right? You have to build on that, right? That process you can substitute this, and you can reduce the risk. You can reduce the risk. Like when you design the formwork system, rather than using a timber, you're going to order the standard formwork system available in the market. It'd be expensive, but you have a high reliability, and the risk is less. Otherwise, I like we put the joist on the top and then sheets on the top, right? Can't do that. Sometimes when you are pouring concrete, right? pour the concrete in the one place, right? Okay, mate, right? Keep pouring in the same place, everything might come down. It could happen. Right? You see that when you eliminate that risk from the timber versus the steel form, you have to pay a price for that. You have to pay a price for that. That's the way the project is evaluated. That's why the very good construction managers, they have that thing with their experience and the instinct they have, they manage them. So the other one, you can engineer and additional safety features to be built in this. Right? For example, when you build the bridge, you've got to always cantilever segment, right? So to construct the cantilever segment, you need to have like V shape angle line, two angle line. You need to attach the cantilever system. Then you need to put your slab. In Australia, the way they replace this one would be this here. This is the common construction. There's a risk when you are doing it, right? That's the intention of the security. This plan is your cantilever section. On the ground, this one we put permanent formwork. So once you place it, once you place the bridge beam, you have a walking platform already. No one is going to fall down. When you pour the concrete, you just need only the edge form. That also we provide bolts and ties to it. In this one also, there's a risk to people. If you compare these two solutions, this one has a higher risk. To reduce that, what you can do, you can provide these brackets and things attached to the precast beam while you are constructing. You are reducing the risk. Rather than person attaching that one on air. You can facilitate that, put beam posts, right? You can put the rod in there, you can tighten that, right? You can connect this one as well, right? Then you can design it and you can place this one in a proper way and then reduce the amount of work you're supposed to do on top of the deck. This is how you're going to reduce the risk. You are not eliminating, you are reducing it. This is the balance you need to look at when you are designing, when we are assessing this. I'm giving very simple examples. This is the engineered solution. We use this I-girder replaced with the super T beam is an engineered solution. Here, engineered solution. Here, it's do the same thing. It's acting as a bridge beam. I'll let the tractor go on top. Yeah, the super T. Here. We use the cement fiber sheet. Yeah. Only one project I use plywood, but the next one they're in a lot. Yeah, CFC sheets. Yeah. But there's now again safety issues. When you cut the CFC sheets, the dust that is cancerous. Yeah. Then we can hopefully go back to timber again. Yeah, you can see, right? That's what I say, you can't eliminate it. Right? CFC is okay, good, and it's durable, but when it's cut, it's created dust, and the workers' health is at risk, right? If you put the timber, it's cheap, it's do the job, like later on it might decay and then fell down into the girder, right? It could happen over the years, right? Still, nothing will happen to the bridge because the load will be taken by the bridge deck, right? So that's why we provide enough reinforcements, but still they think you must not be. There will be balance, and later on they might say you can use it. Or they might come up with a polymer or something. Yeah. And most of the time we design, these are standard sizes. We can manufacture them like a factory made to minimize the cutting in the side. And then the training and admin and these procedures, risk assessment processes, you have to follow. The training they give you when you climb, like working at height, working underground, right? Working near water, right? There are trainings you need to undergo. Then you aware of what sort of risk you're going to face it before you go. Like you learn things in the university. And every day when you are working, you learn every day, like you're young. Every day you learn something when you come to the office, you go home, your brain is expanding, right? You absorb something to your brain. Similarly, we need to have a training. These are the systems we need to implement it. This will make people's life better. These are not complex processes. It's not something people argue, no, it's not. We know nothing. Every time when we do things, we have some knowledge, but the knowledge we don't know is more than what we know. We need to be in that assumption. We have to be humble. So then only we can do things better. That's my whole life experience. I work overseas all the time. I work with many different nationalities around the world in my life. That's what I learned from. And then, this is the PPE. I think you all know, protect yourself. You wear a hat, you go to a site, someone drops the small nail, right? Your head won't get damaged. You get the impact, that will you will get. If you wear the shoe with the toe, steel, right? Casing on the top, right? While you're walking, if you hit something, it won't damage your leg. In the same way, there are a lot of machineries they build now, develop, like grinders and other things. They got a cover, it automatically stops. With the technology, especially AI and other things, they can do this thing better with the electrons. They're much advanced. Not like olden day, like at Moratuwa people use the right? So, like to split the timber and cut. But the thing when I walk around in Sri Lanka, I saw that it used to be the people used to cut the paddy like dark and that. Now they don't use it, right? They use machine to do all the work, right? Yeah, that's the history, like before. Yeah. And these are the thing. When we do the risk assessment process, you can see the least possible solution. Like you can provide is the wearing. I mean, this is the what you can do. But when you do the assessment, you need to make those judgments. Like you trust me, you all are young, but this kind of a process, the people involved is a very experienced engineers. Yeah, very experienced engineers because they are the people like every parties. They sit on a room like this, and then they decide. They go through the process. They identify the risk. It's not only the design or not on the construction, during maintenance, right? During maintenance, you need to, we go through that process. You need to identify something you build, you should be able to maintain. Right? Like for example, in the tall building, we have many in Sri Lanka. You can see all the time you need to clean that window, right? 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 You can see you don't have a steps go along from top to bottom, right? They let the machines to come down, right? Gondolas. People clean it. But there are two people I know around the world, they climb along that one. Like two French guys, right? Just go climb from top to bottom. Spider-Man. Okay. And they sit on a small cage or something. Like a table. A bell. Oh gosh, yeah. Okay. It should be highly paid, right?
But it's not any sort of thing that they
Okay.
depending on.
Yeah, because when you design that one, you need to think about these are the minor thing, like what I want to tell you all, when you walk out from the office, observe the things, right? If you think it is not correct, it's not easy. You take phone and then you can ask the question from the people know better. They have a more experience and knowledge. I think this is it's not right because of this reason. The person asked the question, he should be able to explain it to you. Is it right or wrong for with the reason? This is the way we learn. Yeah. Risk assessment and risk management. Anybody can do this. Everybody can think. So then everybody can think. We can see, we can feel, then we know what to do. Right? In engineering, we have this one. I didn't put that registers. If you need, I can share one of them later. Because I can't open it and put that one so big. The registers to go through this process. Here. So here. When you do the risk, I think like we discussed, we look at the likelihood, the probability we're going to it. Like the classic example I can give, you can think of. When the green light is there, you can walk across the road. I saw many there. Right? There's no green light everywhere. People are walking across the road, right? So the likelihood someone is hitting me is very high, right? Right. When there's a green light for you to walk, you walk from there. Someone said, no one is going to hit me. You agree with me? All right. Someone can come and hit you, but the likelihood is very low. These are the two extremes. These are the two extremes. What are the control measures we identify in this scenario, right? The people you are crossing the road in a safe passage. That's why green light. The other people crossing the road, unsafe passage. Anywhere they like, right? Thankful all the drivers in Sri Lanka, they're very good, they're quite patient, conscious, right? I encounter many. He said, come, and not only that, they jump across the fences and then go across there. Come like jump and then go across, right? Imagine when you jump, if you just lose, I think someone is just drive through, right? The people should not stop, right? They also drive, right? You can't do, if you stop, someone else behind you will hit you, right? Yeah, but these are the likelihood and the consequences as well at the same time. When you do the design and construction process, this is the way we do the risk assessment. We identify the life cycle, issues, causes, consequences. We do an assessment based on the likelihood, identify control measure, the traffic light signal. We put the traffic light and we put the time as well. If the time is not there, people don't know how long you have. Like in Australia, you don't have a timers, but nobody can drive until person crosses the road. That's the rule. Yeah, you can't. Until the person is on the road, it's flashed, the sensors identify. And then you identify the residual risk I talk about. So one is crossing unsafe passage, you are crossing to the green light. And then you do the final risk assessment. This is the likelihood is low. Then you identify risk status and then the risk owner. In your case, the risk owner is yourself and the driver. right? And then action required. What to do, right? The barrier when the people go, right? It's not. To me, the action required to educate them. Tell them to be patient. That's the main thing we need to be. Yeah. One thing I want to share with you, when I drive around after 90s, I came to here in Australia. The road system we have is almost equal to a developed country. The people, the way you use it, is the difference. Yeah. If people use it properly, you can increase the efficiency by easily 100%. That's my experience. I've been traveling to Colombo up and down in many roads around Colombo now for the last couple of days. Yeah. So that's very important. When you do the risk assessment, we always have numbers. We engineers, we always play with numbers, right? We always play with numbers. This numbering system, yeah, you can say, if there's an accident happen, insignificant, no injuries. The way you define no injuries, the first aid box we have in our offices, someone go and first aid box, or no treatment at all, right? And then that could happen, right? Likelihood is extremely likely, right? A certain project, certain element, I'm not going to go this one in detail, it's very subject. Some people put this one like a timeline. Some people put this one certain risk assessment, the cost, you will see the next couple of slides. So then very likely, unlikely, right? Significant injury, reality. So in this scenario, when we get this table, we categorize our risk in high risk area, medium risk area, low risk area, right? If you design properly your homework system or a stair to climb up, right? Person fell down from that one. Sometime you would, as you come down a couple of floors, extremely high, right? Sorry, the incident happened is extremely low, but it could be catastrophic or it could be serious. You see, the outcome is very different, but your risk, when you assess that, come very low. Why? Because your stairs are properly designed, right? Your temporary were properly designed. That is how we use this scale. Is it understood? Any questions? Like you walk through a traffic light, right? If someone hit, it could be here. It's rare. It's a safe passage. You are walking with a grade, you know the time. But if the same person jump in and cross the road, no worries, I'm walking along that, I'm crossing the road. Yeah, you stop your car, let me cross the road. Right? It's my territory, because of that I am doing it. Don't worry. So you can see they are in this category. They are in this category. Yeah. This is something we need to teach when we are in our school. Not up to that extent. Principle, concepts. I'm going to go through this one. These are different criteria we use to evaluate risk. Different categories, safety, and then when we do the delivery, finance, like insurance one, right? We deal with numbers, right? These are the criteria we use to assess the risk, manage it. Because at the end of the day, everything we translate into dollars. Why we are doing it, right? you get proper decision in the risk assessment given the throughout the design life of the structure. The life cycle cost of the structure is very low. You do not consider that one, that's where you're going to end up. That's why engineers in the Western world so conscious about risk assessment. They are not doing it for especially to save someone's life itself. They are doing it for their own benefits. Yeah. So that's the advantage. We need to take this one very seriously. We need to get that one across. It's almost 5 o'clock, right? So, what should I do? Can I continue about not 15, 20 minutes, or I need to stop it at one? Yep. Durability assessment process. I think this process I described in detail in my previous lectures. I will just get in there because you need to design asset lives, exposure classification, the deterioration mechanism. That's where you learn your concrete technology in your about steel, concrete, the unit, right? Then we define what sort of concrete mix and then the cover, etc. How to construct them, and then this. If there's issues, for example, I can tell you that when you are building something close in Colombo, close to the sea, your exposure classification is according to Australia is B2. You have to provide what we call future cathodic protection provisions. That means in the future, you can send the electrical current passing through that one to reduce the corrosion in the steel. You can assess that. To do that during construction, for example, pile, you have to tackle all the reinforcement together. Because otherwise current will go through only one place, right? So you need to identify that. You need to incorporate this one in the design drawing, in your contract document, etc. And you need to maintain it. Right? Yeah, this is the contractually we define design. Like to design a bridge is minimum 100 years. You see here, if you design elastomeric bearing, it's only 35 years. Because the bearing is always subject to unforeseen vertical load, horizontal load, rotation, and so many things. There are a lot of risk associated with that one. According to the experience, some this lasts between 25 to 35. Right? If you get all the concrete structures, like if you get safety straight, protective coating, for example, in the railing, another thing, it's only 15 years. It's galvanizing. So these have a low design. But the rest, mostly, we got a 100-year to 50-year design. When you say this one, it's related to the first statement in the I made in the presentation, need to perform intended function with minimum maintenance. We design bridges, zero maintenance. The plank bridges with strips, unreinforced strip bearing, it could last 100 years. There's no maintenance at all. It's a bridge you can ride. They do inspection, but in terms of the bridge performance, like we use a small joint seal and they need to replace it. But overall, like bearing surface they need to put, but major element like the bearing in here 35, you don't want to do that. Because this is a really big cost. Like while in a highway, when you replace the bearing, you can't stop the highway. If you stop the highway, you can see how much money they're going to lose. Right? Everywhere you drive, they don't give free, right? 250, 150 minimum, right? 150 minimum, right? We change the bearing, but we had to design to make sure that you let the traffic to go. In the meantime, you can replace the bearing. The replacement of the bearing. Yeah, we replace all the bearing together because for example, if you get a 2-span brake, like let's say 5 girders, then you get a 20 bearings, right? So when we want to replace them, we have to design at the beginning, because when you replace the bearing, you have to jack the bridge. When you jack the bridge, you have to jack from the cross beam at the center of the cross. Do I need to draw it, or right? You need to jack from that one. So then your girder will be cantilevered, right? So your girder will be your girders are like that, keeping on the line. You got cross beam here, you have a deck. They will bear the replacement, they have to jack from this one. You see, when you jack the bridge up, it's about approximately 10 mm. This whole way, including the barrier, is cantilevered. But we still let the traffic to go. Normally we close the shoulders and reduce traffic speed. There we reduce traffic speed from 100 to 40 kilometers. Yeah. Because it doesn't matter in a highway if you, while you are replacing a bearing, right? While you are replacing a bearing, you just on one bridge reduce the speed. So you are driving 100 kilometers per hour long distance. But if you stop the traffic, it's a different story. If you stop the traffic, nobody can drive through that. You have to pass through that. This the highway should be designed for this scenario. Yeah. This protective coating and thing, you can close the one lane and you can do, but bearing replacement you can't do with the closing one lane. Yeah, that's very important. All other thing you can do. Deck wearing surface aspect, you can lay halfway through, right? You can lay the other half later. You can manage that with the reduced traffic, managing the traffic. These are the design outcomes. We identify the type of exposure classification, concrete, the mixed design, cover requirement, and how to build them. And the quality control and quality assurance is one of the most important things in the design and construction. They all are governed by many processes. One is the contract document itself, written down what you're supposed to do. Specification. When you build certain specification, 7 days concrete strength is 40 MPa, and you are supposed to do testing. You get the concrete, one batch can carry only 5 cubic meters, then you need to, you say, I test that one, same supplier, that was all right. You just keep pouring. No, you don't do. It is every batch. You take the temperature. Right? There's another huge part we do in it. So you need to have a QA, QC process. The way you need to vibrate, right? So there are so many things we've written down in the specification. Tolerances allowed in the construction, right? It's all governed with the spec. And to quality control and quality assurance processes for the designs, we have a design process. For example, you design it, right? Your senior engineer is going to review it. When he thinks it's okay, then you send to TD. You do an overall review, he thinks this design is good. Then issue for third party to review that. Independent verifier or the proofing. Then they will send you comment. They argue your design against this contract document, including the specification, technical documents, in addition to that design standard. They challenge your judgment. And you need to answer. When you challenge your judgment, you say, no, I got a 25-year experience. I got that much of education, therefore I don't care what you say. No, you can't. You need to encounter in your life. You design, your client engineer might be only 3 years experience. Professionally, you can have a both respect, massive respect you may get from them, but you have to answer his question. Professionally, you have to answer his question. It's not your experience matters. He asks you a question, you have to answer that. always be polite and humble, right? Yeah, we are not perfect. We are not always right. Someone can challenge what we are doing. We need to take it positive. Yeah, we need to take it positive. So that's why these processes we put in addition to that, right? If you go through the right process, I always give this example, the water quality in different countries, right? You don't want to name countries, you all know different countries, you travel around. Some countries you go, you only go and drink Coca, nothing else. And so the verification processes and the compliance checklist and thing, these documents we developed to make sure that the designs, construction processes, follow a process, we can get the better outcome. Why we are doing this one, every time if you make a mistake in your design, contractor will raise RFI. It will take about 2 to 3 weeks for him to go back and build it. At the end of the day, he can claim against you. Then your insurer has to pay him back. Otherwise, you will end up in the court. Both of you is going to pay for lawyers. Yeah, don't do that. Yeah. Have a coffee, the tea, talk to each other, be cool and tell the story, and then yeah, if you go there, we both waste our time and money. Yeah. Try to find a compromise solution. But if you go through these processes, at least you got evidence. At least you got evidence. You did the right thing. We are humans. We are reasonable. Right? This is what I always tell. I always tell my engineers, I never think I can do everything. If they point out to me, we can do that one, I say, yes. Why not? We try it, we do it. Sometimes even if they're not right, I let them to do it. Because I want them to learn by mistake. That's how we learn. That's what we learn. That's how we learn about it. So, but these documents and these processes, they are governed by them. Even in the construction, the specification, method statement, risk assessment, and RFI and CR process, safety, and this auditing is always there. These are the mechanisms they set up to make sure that we deliver the product. Let's perform the intended function. There are a couple of words I mention all the time. Yeah. And these are the quality assurance and quality control processes. You all can go through them. If you have questions, you can write to me. Yeah. I just script through these slides. And then you got documentations, spec, drawings, reports. Reports are very important thing. I suggest Shiromal to start that culture in here. I can give the examples to let the engineers to more familiar with writing a report, to understand the contractual requirement, not only the requirements in the standard is nothing say, but other requirements. The interfacing, for example, to do, then you document that one. So then someone work here and he'll leave to another organization. So then the person who is picking up, he really know what is exactly the person did. Yeah. Then that's very important. And then we normally document everything, issue registers, small issues. You can put the register. Sometimes you need information from a client. You need to get some information from your stakeholder, like a service provider. Sit down electricity board, you need to get. Then you have a conversation with them. You put a date and he didn't send it to you. But if you keep those documents, dates and everything, agreed documents, agreed dates, emails, that contractual evidence that you did the right thing, they didn't comply. That's where we doing it. Risk register, compliance register. What is the compliance register? That's the contract documents you need to list up. For example, type of barrier used in the bridge. Client always say we need medium performance barrier, TL5 barrier. Then you need to say, yes, we use this one. This is a section of my report, I document that one. This is the drawing, you can go back and see. Someone say in the audience or somewhere, why do we need? It's already in the drawing. We need to go back and read it. No, we don't do that. If you go through that document, this is one example, there are thousands of things you need to check. Then you will find I never missed out anything. That's the difference between us and Japanese. The quality assurance, quality control product is 99.9 something. Just they go through each and every line, each and everything. That's what you all need to learn. You have to work with more, but you will see self-satisfaction yourself at the end of the day. Design tools. Like that couple, the husband using the hammer, right? When you use designs, you got a standards. You're going to contract your document, design charts. When we UAE, we use design charts. And then analysis softwares. Now you can do structural analysis. You learn with moment distribution by hand today. You are just running a software and Midas and telling me, yeah, this is Midas output. This is Midas output. It's not my design, it's Midas state. I know what you are doing, right? Then design softwares, worksheet you do. Modeling softwares like plot modeling, for example. Right? And the construction also, equipment, tools, and management system. You use SharePoint, for example, in the design and project-wise, put everything and everybody can see, everybody can work together at the same time. Right? We use in the work. Even the maintenance, I don't have much idea about this, but maintenance, we provide the asset numbers. Now the way of with the AI, we are using the 3D modeling current asset numbers, each and every one, they got a number. They got in that database. When you click that, it will go to that place, it will show the location. Yeah. Back then we call this steps. Now it's not. Right? We call it stair back then. It's one element. Now we call it steps. Stair got 15 steps, right? 13 steps, 10 steps. Then the assets numbers they got. The number 2 got a damage, and they know that number 2 got a damage, they repair it. 50 years, 30 years, 40 years later, someone look at that, they knew that that particular date has been repaired. That's why this data based on this with the technology that they're using that. There's a lot of economy people think they can achieve with this. The conclusion with my presentation, I'm going to conclude the presentation like this. With engineers to understand you need to understand the overall process. You should think out of the box. Understand bridge will designed to stand for unforeseen forces. It's not the one in the code beyond that, the flood. Environmental factors. It should be stayed over century, used by future generations. You are designing for yourself. Not for you guys, right? Understand you are spending your own and your children and grandchildren as the future. Right? It's very important. Someone else can do wrong thing, but you should not. You think beyond and enjoy what you are doing and building. This is what we still love this profession. That Shiromal is sitting there. Otherwise, we don't want to do that sort of thing. We can retire, we can go around and we can enjoy our life. But still, we still love to do this. Yeah, because we enjoy. I really enjoy talking to you. Yeah. So that is all about. So trust me. If you are a good structural engineer, design and build around, it will coming up everywhere, especially in Sri Lanka, coming up everywhere. You go around, you look around, you can show it to your friends. You can talk about the rest of the people, they can't. Yeah. You have been in a elite club, be part of that. but you need to do a lot of hard. You have to do a lot of hard. Yeah. So I would like to conclude my presentation. If there's any questions, I love to take them. Yeah. I'm really sorry I went a bit of over time.
That's all right. So yeah, there are a couple of questions from the audience.
Yeah.
So the first one is, I'm not too sure as to what he's exactly referring to, but he says, why do girders crack during stressing? Just reword it.
Okay, he's asking about a technical question, like when you pre-stressing, the girders crack. Yeah, of course. When you design a pre-stressed concrete girder, that's the one thing we do, you have to check the girder for the transverse stress, right? So if your flexural tensile stress, because your concrete is young, then your strength is very low. That's why normally pre-stressed concrete girder design, you get the concrete batch and you check the 1 day, 3 days, 7 day, all this 28 days strength. So if your strength is not sufficient, definitely it will crack. Yeah, it will crack. So there may be other reasons as well. One of the main reasons is that.
Next is, what are the critical issues that you have come across when designing a skewed bridge in your experience?
A skew bridge. The skew bridge mainly you need to do the complex analysis. If you not properly design and construct, the bridge will crack. Yeah, when you cure the deck, it will crack. In the same way, if you not properly design the bridge and detail it, the bearing got a very lesser design, like we say 35 years, it's less than.
I'm rewording some of these a little bit. So they have asked, I think what they meant is, what are the considerations that you have when you're designing a bridge with the vehicles moving both ways? So yeah, that's what they've asked.
Yeah, when a vehicle moving both ways, there are two approaches we use in the design. The one approach is you can see I know where it's coming from. Like you are moving this way. When you design a bridge, you have to design for horizontal load, braking load is a really big load. So when you brake that way, the bridge will moving that direction. If the vehicle is moving other direction, at the same time, if you consider the braking load in other direction, it will cancel out. That is not the case. And that sort of bridge, when we design, normally the client will ask you to assume the traffic is in the same direction. You need to consider that scenario. Yeah. The other scenario is for you to my experience when you design the bridge, whether it's the one way or two way, inbound or outbound, you get the same, basically the same effect, because you loaded on the one side of the bridge, that will give you the critical loading, even in the substructure, superstructure. Yeah.
I think this one you have answered, but they have asked, what are the software that can be used for analysis of bridges?
You can use any software. Only thing you should know how to model that. You don't want to go. There are built-in softwares like the Midas SAP, got a bridge design module. Right, the SAP is a program originally used mainly for ETAPs or building, say for foundation. Then later on they develop SAP bridge version. You can use it, but you can use any software, any structural modeling softwares. You don't need bridge modeling softwares to analyze the bridges. In my next bridge design series lecture, I will explain you each and every element in the bridge, how to replace with the beam line element, and it can model in any software. Soil structure interaction, how to replace with the spring substances. You can model in any software. Yeah, the results are very accurate. But I need to tell, like if you analyze the continuous span post-tension bridge, if you want to get the secondary effect of the creep shrinkage and those things, then if you go to softwares like Midas and specific softwares, then you get more accurate results. But still, you can use the first fundamental. You can use it, for example, the temperature variation in the bridge, increment in the temperature, increment in the bridge, we apply that one, that as a temperature along the beam line. Then you can get the deformation of the bridge. But if you go to a built-in software, you can tell the program what is the temperature, then it got a different algorithm and different I should say structural analysis method of finite element models they develop. I think you can use them. Yeah, we tested this one, especially for the continuous.
The next one is, do you need to provide dowels at one end of a supported bridge?
Not exactly. The bridges, there are two types. One is for example, the bridge itself, you call the bridge, you use a slab. Like if the span is less than 6 meters, we use this concrete slab as a bridge deck, a superstructure. So in that case, sometimes we use the dowel to hold the bridge. There are different ways you use this. Another one, we use the dowel to connect the bridge superstructure and substructure together. That type of bridge we call semi-integral or fully semi-integral. Yeah. The various bridge type we use. Yeah. But not every bridge. It's depending on the type of the bridge. We use the dowel to connect the approach slab to the earth in the bridge. Yeah. I can send you some of the drawing and detail, and you can pass on to the person who asked the question.
The next question is, when vehicles are in motion, this you may have answered, they cause vibrations on the bridge, especially on highways. So how do bridges either withstand the damage due to these vibrations or bear them without collapsing?
Yeah, I think the bridge vibration, we call the vehicle and the bridge, the vehicle interaction, as one of the area in the structural dynamics. For example, when you are doing the pedestrian bridge design, we do this analysis like when the people is walking, right? The process we do in the pedestrian bridge. We find the natural frequency of the bridge for the different mode, and then we put like in the Euro code and the other codes they give you. The weight of the person is 70 to 100 kilonewton. 70 kilogram or 700 Newton. You apply that load, but that load with in the sinusoidal or cosine curve, but with the natural frequency, if we use the natural frequency in that the pattern you get. So that generate the resonant effect on the bridge. Yeah. But for the bridge design, the way we do, it's very complex, and we are not going to do that in that way. We basically, what we do, we're going to increase the bridge static load by what we call impact factor. Yeah, impact factor. But the impact factor what we use in the bridge design ASHTO, it's very low compared to Australian standard, like we go 35%, increase the weight. So we increase the weight of the bridge, the static load. Because if you are doing a normal bridge with like a dynamic analysis, it's very difficult, especially to convince the client what you're doing is right. That's why it's codified. But it's a different story if you are designing a cable stay. You have to do a proper dynamic analysis. That's like software like Midas. It's allow you to model that one. It's different in the construction stage, in different stage we do. But to answer the question in like a one-line statement, dynamic effect on the bridge, of course, we take into consideration. The one approach is the fatigue design. If it is a steel, is quite critical. The concrete is still we check. If you go to any design standard, they provided you, especially like a railway bridges, fatigue critical. And in addition to that, we got what we call the impact factor. So we increase the static load by impact factor. There are two design approaches we use to take that one into account in the design.
The next one, I'm not too sure, I don't think it's a question, but someone has just said that the design of temporary structures is similar to other structures relevant to the code, where the codes have to adhere. However, many codes differ by means of design life and road intensities by return period. Is that correct?
I think that's what, okay. If I give you an example, if you want to design a scaffolding system, it's going to subject it to wind, right? So when we design the structure, we got the wind SLS and ULS. SLS wind like in 1 in 20 year return. ULS depending on the type of the structure and the category. It could be 1 in 1,000, or it could go up to 1 in 2,500. So you need to, you can get the loading based on the code, but I still need to make sure that it's very subjective. If you design that the bridge across the Kalani River, the wind analysis, the temporary work design analysis, very different. If you are just designing a bridge scaffolding system or the scaffolding system to construct a slab. Yeah. The client doesn't say some codes specify, but it's make the engineering judgment. It's a contract documents, say what sort of loading you need. But of course, loading, if you put, for example, big, heavy machinery, you let run next to the your temporary excavation. So you need to get the distribution of that load under the ground. So unless otherwise you do a Plaxis modeling or something, you can use the design standard to evaluate it. Yeah. But I say not directly written down in the code in the sets to say use that load. When you check the steel concrete, when you design, of course, you have to use the code, but the overall principle is there, the responsibilities. And you design for 1 in 20 year return period, then you design temporary work. It's never stated, right? You design your factor of safety 2 times that one. They never design that because it's very expensive, right? With the temporary work, when we design, you can monitor. There are many approaches you can eliminate the risk. So therefore, there's no one solution as. But as of course, you have to use the code to design because you have to check your members and everything. Of course, you have to use the code.
Try to rush through the next few. Someone has asked, can you explain the process of load analysis and how it influences the design of a bridge to ensure safety and functionality?
I think I suggest them to go back to that the lecture series. I think
I'll highlight that at the end as well.
Yeah, third, fourth one. I think you will learn that. I spent almost 7 hours. I think talking about bridge loading. Yeah.
So whatever that can be covered by that, I will highlight that at the end.
Yeah.
So that we can save a bit of time. The next one is, what are the strategies that can be used to reduce the cost while meeting design requirements?
Yeah, the strategies is the value engineering talking to each other. Yeah, I think the one process is the designer, client, contractor work as a team, not in the triangle and pulling with each other. Yeah, that's a simple answer I can give. And do the value engineering because client should not think I am the boss and you do what I ask you to do. I mean, this is strong language I'm using, I'm sorry. But the contractor say, I'm the one who's building, I want easy way to build it. Designer say, no, I'm the designer. I like to do this one. Conservative and something like that. Doesn't work. We call value for money for the project. You identify the issues. Some issues is very simple, like you design a structure, you think is economical, but the contractor think is going to build, it's cost you so much, right? For example, like I said, the wider slab bridge is not economical, but in Australia, it's consumed a lot of carbon and it's concrete, but it's still compared to overall cost, compared with the labor and the spans we can go, it's cheaper, but it's not in here. So 3 of them need to work together. And then you have to go through the step by step. You need to identify the issues. Like I said, you need to create that issue which is there. You need to find the mitigation process. And then those things three parties agree together and implement. Even if you think it's a design only one, so you need the designer and the client need to work together. Yeah. Sometimes the designer need to educate the client. The same way, client need to educate the designers. There are specific requirements. If I give an example, sometimes because when you the everything we get the finance like infrastructure project, it's coming from parliament, they approve, right? Or funding agencies, they have their own requirements. They need to comply with, right? Those things client need to properly give it to the designer. Then only they know, otherwise they don't know. Right? You need to properly tell what is his requirement is, then the designer can come up with. But designer and the contractor can come up with the alternative solution. It's not challenging. They think this, they could give more economy, more efficiency. With our experience, then we need to take a balanced approach. That's the way I looked at it.
The next one is, when designing bearing pads, what loads should be considered for ultimate and limit state load design?
You need to get the maximum reaction on the bearing. First, when you model the bridge like a 3-dimensional, you always get, like when you run the bridge, the like we call influence line, you get the maximum reactions on your girder, because this maximum reactions on the girder is not coming, putting the load directly on the top like that scenario, right? You get the maximum load when it's cantilevering in there, right? You need to consider those load. You need to get the maximum load, then it need to go through that. You need what we call the load path. First is the deck, from the deck to girder, girder to the bearing, the top plate, and to the rubber pad, bearing, elastomeric bearing pad, then to the mortar, then to the ground. Yeah, so we need to consider each and every element. For example, if you get the rubber, the maximum the SLS compression we allow is 10 MPa. But if you look at the bearing capacity of a 40 MPa concrete, right, depending on the size of the area, it could be go up to 1.7 to 2, right? But you limit your bearing pressure on the rubber to 10, but your concrete still can go to 80. That doesn't mean you go and use a 20 MPa concrete. Right? You can't use it.
Speaking of 20 MPa concrete, someone has asked, in Sri Lanka, we use a mixed ratio for grade 20 concrete. We use 1:2:4. But in India, they use 1:1.5:3. Which one is correct?
No, I can't. I'm sorry, I can't answer that question. But now we don't want to. Yeah, if you still use, I think better to do a test. Yeah.
Then the next one is, in the skew bridge, pier cap shearings to be provided perpendicular to the main bar or in skew direction.
You can do either way. If you sorry, it's not coming to my mind that there's an analysis method. There's a paper in there. I will send it to you. You can give, but you can put either way. But it's easy to put that one in the perpendicular direction, because when you lay your reinforcement, the bridge is askew for the same reason, but your reinforcement need to be perpendicular to the traffic, right? Your flexural analysis, the structural reinforcement should be perpendicular to the traffic. So because of that, you are not putting your reinforcement in the skew direction. I think that's a standard practice. You put in the perpendicular direction, so you can lay your rebar in a proper way and need. I forgot that particular the analysis method we use. It's not come to my mind now, but I will send that paper and you can read through that. Yeah, some of the courts already refer to that one and send that paper to analyze the scale bridges.
And 4 more questions. Can you describe the action of a jacket wall, which is used to protect cracked abutment and wing walls?
Jacket is easy to talk about.
I'll just repeat it. Can you describe the action of a jacket wall, which is used to protect cracked abutment and wing walls?
Yeah, the wing wall we are putting on the side of the bridge to because the bridge we build in a higher level, so we're not allowed to soil to spill out within the certain distance within the bridge curtain hole. And I'm not sure the technical terms they call jacket hole, but if there is a crack, there are so many ways you can repair it. I think now the modern day we use fiber reinforced solutions. They're cheap and easy. Yeah. You don't want to go to heavy construction now. I think technology is moving really fast here. Like I mentioned before, now modern day bridges, it can survive in the future when we like come to our age, another 100 years easily with all this, like sticking a piece of paper on the bridge. Yeah, that technology is good. That part, yeah,
Self-healing, like self-healing concrete.
Yeah.
The other one is how to conduct a condition survey for an old bridge.
That's the long process to do. That's the first thing is to depend on the type of the bridge, right? You can do a visual inspection. If you get the bridge, I think when you do a visual inspection, you can see the bridge they crack or those things, and the bearing, and especially the main. I think the culprit in the bridge is the drainage. Well, we designed the bridge for to carry heavy load, but we don't design properly the drainage. Yeah, that will kill the bridge like a cancer. So we need to look at that. Yeah, there's no the list of things you have to do is depending on the type of the bridge, age of the bridge, the type of the material you used before, and that sort of thing. But I asked them to do it in a right way, identify all the elements in the bridge, from the railing, to the barrier, to the deck, girder, bearing, mortar pad, like cross beam, column. Yeah, you can't see underground. And look at the bridge surrounding behind the back of the abutment, curtain, mold, ladders, approach slab, and those elements. And then go back and identify the defects in each and every element, and then see how important those defects for the performance of the bridge. For example, the railing, in the bridge railing, the car hit the bridge railing, is bent, right? You don't want to replace that one immediately. But if there's a crack in the bridge, or the bearing is warped, right? You need to replace that one immediately. So these are the way you can make your judgment when you do the conditions.
I think we'll take one more question because I got a couple more, but we'll take one more. Sometimes we have to do foundation designs without boreholes, just hand auger tests. Is that okay?
That is not okay. That's got a lot of risk. So what you need to do, you need to, like for example, the very experienced geotechnical engineers, when with their experience, with their work, when they go around the area, they know the geology, the soil profile in that area. They can make a judgment, right? But still there's a lot of risk. Like if you actual pile length, if you say 30 meters, but in the site, if it is a 45 meters, yeah, the client will, right? He has to sometimes stop the project, right? The cost escalation. So because of that, the contractor need to specifically write down in the drawing the loading. Normally we specify what is the loading on the pile, what is the maximum bending in this pile, what is the required socket length, like if it is a friction pile or end bearing condition, these requirements in the drawing, in the tables. Then you need to put on a note, propose borehole. Before you start construction, right? You need to do a borehole in this location and justify your soil profile, and it need to be sent to designer for his approval. Right? Based on that, we're going to adjust the pile length. Then in terms of if it's a private client, the designer needs to educate the client to make sure that he know that there is a risk. We didn't do borehole for reason, right? Like for example, if you design a building right somewhere next to a existing building is already, you need to use it, you can't do borehole in the middle of that one. So we need to take that risk, right? And we need to make sure that we do all the compliance testing requirement before we start construction.
So if you learned something today and if you wish to learn more about bridge design, we actually have unfortunately unfinished, but a very comprehensive bridge design series available on our YouTube page. So you can just check our playlist and you'll find all the videos over there, and you can ensure you if you watch today's session, you know that you can learn a lot from that. Additionally, if you're interested in any of the other webinars that we've conducted so far, we have a playlist there as well. Everything's made available and you can watch it, and we hope that you benefit from that.